The Moon, just like the Earth, has a pretty epic geologic history. The lunar surface has never supported life, never had tectonic plates, and never had sedimentary rocks. Instead, this is a story of oceans of lava, epic asteroid strikes, and the cooling of our cold, solitary celestial neighbour. And to keep track of time, just like the Earth with its complex and intriguing geologic timescale, the Moon has its own separate timeline of geologic periods. Let's talk about the annihilating bombardments of the Nectarian Period, the spectacular bright rays of the Copernican craters, and even the Moon's first visitors. Let's explore the geologic history of our Moon. The Moon was formed in the very beginning of the Hadean Eon of Earth's history, soon after the Earth itself was formed. Sometime around 4.5 billion years ago, it's believed that another planetary body called Theia collided with the molten Earth. This is called the Giant Impact Hypothesis. This impact devastated Earth and disintegrated Theia, blasting massive amounts of material into orbit that might have briefly given Earth whimsical planetary rings. Eventually, these molten rocks coalesced into the Moon. The Moon's formation kicked off its first period, the Pre-Nectarian. The Moon was hot and covered by a glowing ocean of lava which began to cool. Heavier elements like iron sank to the core, while lighter elements formed a crust of igneous rocks, in particular anorthosite and basalt. Sometime early in the Pre-Nectarian period, after about 100 million years, the Moon became tidally locked with Earth. Its orbital period, the time it takes to rotate around Earth, and rotational period, the time it takes to rotate around its own axis, became exactly the same. The Earth's gravity pulled more strongly on the near side of the Moon, and from this point onwards, we would only ever see one face of the Moon. Towards the end of the Pre-Nectarian, a period of intense asteroid bombardment began, called the Late Heavy Bombardment. It was probably caused by the erratic orbits of the large gas planets disrupting the asteroid belt. Some of the Moon's largest asteroid strikes occurred here, including the formation of the Oceanus Procellarum, the largest lunar sea, and the Mare Nectaris, whose formation started the next period, the Nectarian. The Nectarian period was an intense time for the Moon, as the late heavy bombardment continued to batter both the Earth and the Moon. It is named after the Nectaris Basin. It is a lunar sea, also known as a volcanic plain or lunar mare. There are a number of lunar mares on the Moon, which we see as the dark areas. Many of them formed in the Nectarian period after asteroid impacts of colossal proportions punched craters into the Moon, some of them the size of European countries. Other lunar seas created during this time include the Mare Humorum, Mare Frigoris, Mare Serenitatis, Mare Crisium, and the Mare Imbrium, which marks the start of the next period, the early Imbrian. By the early Imbrian, many of the Mare impact craters were established, but now these low-lying areas began to flood with lava from the Moon's many volcanoes. Eventually, this lava would dry into smooth, dark plains of basalt. This process probably continued for several 100 million years. The early Imbrian was short and transitioned to the late Imbrian with the formation of the Oriental Basin. The late Imbrian period was where the Moon's volcanic activity reached its peak, and many of its basins were completely filled up with basaltic lava. Now, the Moon had defined contrasting areas, with dark lunar seas and the lighter highlands, which are older and heavily cratered. The Maria are significantly smoother due to their relatively younger age, and the cooling that occurred after volcanic eruptions. The Eratosthenian Period was when the volcanic activity of the Moon declined sharply. The Moon's interior had cooled so much that large-scale eruptions had stopped by about 2.8 billion years ago. The Moon was still receiving asteroid hits throughout the Eratosthenian, like Theophilus and Cyrillus. Typical Eratosthenian craters have minimal erosion and don't have bright ray systems that we'd see in the future. The Eratosthenian period is where the Moon accumulated a lot of regolith, a layer of fine dust and rock fragments created by erosion and smaller impacts. The Copernican Period is the most recent and current geologic period of the Moon. It is distinguished by the formation of relatively young craters, such as Copernicus and Tycho. Impact craters from this period are relatively fresh, with sharp features and lines that spread out in every direction, called ejecta rays. The lack of volcanic activity during this time allowed these craters to remain mostly undisturbed. In 1969, the Apollo 11 mission landed on the Mare Tranquillitatis, the Sea of Tranquility, and Neil Armstrong and Buzz Aldrin became the Moon's first ever visitors. Across 6 lunar missions, astronauts collected rock samples, planted flags and scientific equipment, and left commemorative items. Thanks to these missions, we now have a lot of information about the rocks, impacts, and volcanism of the Moon. The Moon is still in its Copernican period, and it's cold and quiet. With no volcanic activity, no atmosphere, and no hydrosphere, it's considered to be geologically dead. That being said, there actually is evidence of mare ridges on the far side that formed relatively recently, in the last 200 million years or so. So, the Moon might still have some action left up its sleeve. While the Moon might just be a cold, dead space rock, ever since Homo sapiens started looking at it, it has taken on a whole new kind of life. For lunar observers throughout human history, the Moon's phases and cycles were recognized as influencing tides, planting and harvesting, and even human health. The Moon was an important figure in ancient belief systems, personified by the goddess Selene in ancient Greece, Luna in ancient Rome, the god Khonsu, the traveller, in ancient Egypt, and Ishel in Mayan culture. The ancient Greeks were the first to recognize its physical nature, and correctly deduced that its glow was caused by sunlight. Over the millennia, and still today, the Moon represents fertility and motherhood. It represents mystery, magic, guidance, and light, and one half of a light-dark duality with the Sun. A full moon represents madness in medieval lore, and is tied to legends of werewolves and vampires. In a playful or artistic sense, the Moon is a wheel of cheese. It's a powerful dappling of yellow paint on Van Gogh's Starry Night. It becomes human in Dali's The Moon, and it's inspired musical pieces from Debussy to Beethoven to Dean Martin. We have flags with the Moon on them, and a moon with flags on it. So, what's next for the Moon? As it moves away from the Earth slowly, about 3.8 centimeters per year, eventually its time will end as our neighbour. While it could potentially drift off into space in about 15 billion years, more than likely it will be engulfed by our Sun as it turns into a red giant in 6 or 7 billion years. But for now, whatever the Moon means to you, it's not going anywhere anytime soon. Thanks for all the support with this series. I hope you enjoyed this kind of short video, and if you haven't already, spread the word, give a like, and subscribe.